Okay, so welcome back to another video. So here today we want to find all natural numbers n such that 19n plus 17 divided by 7n plus 11 is equal to a, where a is a natural number. So of course we don't really care what exactly that value of a is equal to, we just know that it has to be a natural number. So typically with number theory problems like this, when you're trying to find natural numbers to satisfy an equation, you can sit here all day and actually just plug in all the natural numbers, the infinite number of natural numbers into the solution to see if it does indeed come out as a natural number. But, we're not here to do that because no one wants to, because that's going to take a long time to do all this. So with strategies like this, you actually want to be a little creative here. So first thing, I think it's worth noting that what I'm going to do is, and this is the first step, is that we're actually going to multiply a natural number from both sides of the equation that still preserves the idea that both sides are actually going to yield out a natural number. And by that, and the rest is using a little bit of algebra, and by doing so, because specifically a natural number we want to multiply with is going to help us do a little bit of manipulation on the left side of the equation. You'll see where I'm coming from with this. A little bit of algebra will come a long way, and then eventually we're actually just going to do a little bit of observation to see, what kind of natural numbers actually satisfies this following expression without having to plug every single natural number of our choice into the equation, because, as I said, it's going to take forever just to do that. So let's actually just jump right in. So as mentioned, if I want to use a little property, I'm just going to multiply capital B to both sides. So I'll say first that the property A times B is going to equal a natural number such that B is also a natural number as well. So with this, let's actually suppose if we let capital B equals the number 7, right? Now, of course, as I said, we can actually choose whatever number of natural number B we want as long as it's a natural number. But choosing the number 7 specifically is going to make things a little bit easier for us as we, compute all this sort of manipulation with algebra. And you'll see, exactly what's going to happen from here. So multiply 7 to both sides. So now that would mean, and I'm just going to reverse the side. So A will go on the left and then our expression will be on the right. So this will be 7 times A. That's actually going to equal to 19 times 7n. And then add this with 17 times 7, all this divided by 7n plus 11. Now let's actually do a little bit of algebra over here. So what I'm going to do for this 17 specifically is I'm going to actually write this as a subtraction of numbers. Specifically, I'll write this as 19 minus 2. And then the next thing we're going to do is we're going to add and subtract a 19 times 4, which that's going to equal 76. That number 76 is not important. What's important is that the composition of the those two numbers. So what we have is 7a multiplied by 19 times 7n. Then I'll write this as plus 7, then multiply with 19 minus 2. Then add this with 19 times 4, subtract 19 times 4. Then all this is just going to divide by 7n plus 11. And so what I'll do is I'll factor out a 19 from both the 7 being distributed to 19 and then the 19 over here being multiplied by 4. And so I'll have to, don't forget, distribute the 7 to the negative 2, so that'll be negative 14. And so here, this is where we're left off with. So we have 19 times 7n, so nothing's being changed over here. Then next is, now group this as plus 19. Then this is coming from the 7 from here, and then multiply, so this will be a plus 4. Then we have to distribute the 7, so this is minus 14. And then I just multiply the 19 times 4, which is minus 76. Then, of course, all this being divided by 7n plus 11. And so now just doing a little bit of, distributing. So 19, 7 plus 4. So this, the inside expression is going to be 11. And so again, I can actually factor out this 19 again. And so this means we're left with 19, then multiplied by 7n plus 11. Ooh, this is very interesting as we see. Then minus 14 minus 76, that's minus 90, all being divided by 7n plus 11, and just say that this is still equal to 7a. And so, we can actually just split this up into two fractions, and you'll see that the first part, 7n plus 11, cancels both the top and the bottom. So this will be left 19 and then minus 90 divided by 7n plus 11. Interestingly, obviously we know that 7a is still going to be a natural number. That's the least of our worries. We're trying to show that we have to find some natural number n such that it satisfies this following. Again, both sides are, we have to our main issue arises is looking at this fraction over here, this rational function, as we'll say it in this sense. 19 is obviously a natural number, so we have to find some n such that this fraction is going to end up as a natural number, so that with the whole operations, everything from both sides will yield a natural number. Let's see, I'm going to put this statement, find some natural number n such that 90 divided by 7n plus 11 is going to be a natural number. And so we're actually going to use a little bit of this inequality. So let's see, if we set 90 equals or greater than or equal to 7n plus 11, this will actually help do a little bit of observation to see what choices of n we can find to satisfy that the whole thing becomes a natural number. That's the main takeaway of doing this little observation. So we actually solve for n, so we see that this is actually just going to equal, so I subtract 11, so we have 79, then greater than or equal to 7n, divide the 7 to both sides, then I have that n is going to be, it's still going to be less than or equal to 79 divided by 7. That's a rational number, but we can actually fix that up just a bit. Or I can write this as 11, add this with 2 over 7. If we take a look at this, so we had to look at this from the extreme left-hand side and the right-hand side. So let me underline this and then this. N is less than or equal to 11 plus 2 over 7. So 11 is a natural number, and then 2 over 7, that's a rational number. Okay, so what kind of natural numbers n can we choose such that the following inequality here is satisfied? As you can see, obviously for all natural numbers, we can see that our choices for n has to fall in between 1 less than or equal to n less than equal to 11. All right, and so now the last thing basically is you can actually just plug in all natural numbers 1 through 11 to this equation over here to see if it yields a natural number. Not surprisingly to see that the only solution to this is actually n is going to equal 1. As if you plug the other natural numbers, everything from this expression is actually just going to yield out a rational number. Hence, a natural number minus a rational number is going to yield out a rational number for this expression over here, which is not what we're trying to do. We're trying to find a natural number n such that this whole expression satisfies that the right-hand side, capital A, is a natural number. So I'm going to box. So therefore, our final answer is going to be n. And then let me write the justification and say that all other n's will be rational. So that's a little bit of statement to that's important to justify over here to see why we have our final solution over here. And so there we have it. N is equal to 1, and you can see that if you just plug n is equal to 1, so 90 divided by 7 plus 11, so what is it, 18, so 90 divided by 18 is 5, that's a natural number. 19 minus 5, that's a natural number. Now you could have just solved for AA's too, and it's a natural number. That the whole thing is going to be a natural number, even if you were to plug this in. 19, for n is equal to 1, 19 plus 17 is 36, and then 7n plus 11, so that's 18. 36 divided by 18, 2. 2 is a natural number, n equals 1 is the only solution to this following expression over here. So yeah, that's pretty cool if you ask me.